Wonderful. So we are working in work package 3 with the monitoring, and you see here just briefly displayed our team. It's me for the supervision. Luis Porras is our PhD student, the early stage researcher who's just arrived this week from Costa Rica, so he's here now. And we have Dr. Ivo Havlik as technical support in the background. He was the original applicant for the project and is now already in a retirement, but he's still there and helps to get along with the project. So just to show you, we have several milestones to reach. I don't want to go too much into detail, but we have, of course, to present the data integration platform and develop it also. We have also to develop some optical sensor hardware and then combine everything at the end to a working soft sensor application for the microbiology documentation and monitoring. You see here a nice view of our culture labs. This is how our infrastructure looks like, so we're quite well equipped. We have 2 secondments also to fulfill, but I think this is too much details at the moment. Deliverables, we have 2 deliverables. First, the description of the data integration platform. So the theoretical framework for the software development, and the demonstration as a second deliverable, the demonstration of the newly developed non-invasive online optical sensor. And as you can see here in the sketch, we work on the bioprocesses with variable sensors that we can apply here in Hanover, from NIR over fluorescence to chemosensors, and we can apply them non-invasively, inline, at-line, online, anything you like. And we are working with organisms from prokaryotes over mammalian cell culture to microalgae. So we are, I think, quite able to cope with all these problems. And also we have a bioinformatic groups that supports us in the project for the design of experiments, for example, and for the bioprocess modeling and the machine learning algorithms we want to apply for the results and for the findings of the project. So our objectives are first to develop a non-invasive optical online sensor on the basis of multispectral reflectance and absorbance. For example, a fluorescence sensor. You can see here also a fluorescence spectrum in the sketch here, where you can see all the different fluorescence activities occurring during a cell cultivation, a typical cell cultivation, and that is where we want to derive the information for the software sensing from. We also will rely on PO2 sensing, on turbidity sensing, and everything that is also further needed and can be applied to get useful insights about the ongoing process. The aim is to get information about the microalgae culture fitness, the physiological state of the microalgae cultivation, and of, if possible, concentration of selected intercellular metabolites like pigments. You saw just in the last presentation that there are carotenoids, for example, or other products as lipids of interest by microalgae cultivations, and that we can hopefully also get some details on, so can be able to monitor them. And expected results from us are an at-line sensor system, for example, a fluorescence sensor system like you see here in the small sketch above the picture, where we applied a fluorescence sensor for specific wavelength pairs excited by LED light and detected by photodiodes. So very easy and robust applicable sensor via fiber optics. And you see the application down here in the picture where we built up such a sensor already for another project concerning bacterial cultivations. And this is what we want to adapt now for the microalgae cultivations and combine it with the other sensors that are present here for oxygen concentration, turbidity, and other UV-vis sensors. So this is about what we are going to do, and we hope that we can get multiple informations about the different microalgae that can be cultivated in the project, and that we hopefully get some model organisms also from the partners we can try our sensors on and gain knowledge about that.